here's one famous aetherist, 18th century. And this is what he had to say about ether and gravity, how the ether causes gravity, or what the mechanism is. And his name is Euler. That's after he took some ether and went to his head. And no, that's not what he looks like, but I think that's what happened to him. He just took a lot of ether and it went to the, to the ceiling. Anyways, this is Euler here, okay? And he says the following. He says, those who attribute gravity to an attractive force of the earth base their opinion mainly on the fact that otherwise no origin could be displayed for this force. But since they proved, I like that, they always prove, right? That all bodies are surrounded with ether and are pressed by the elastic force of the latter, we do not need to search elsewhere the origin of gravity. So you can see that he's already figured it out. Only if the pressure of the ether would be everywhere the same, which assignment is indistinguishable from that of its equilibrium, would the bodies be equally pressed from every side and thus would not be induced in any motion. But if we assume that the ether around the earth is not in equilibrium, and that instead its pressure becomes smaller as one comes closer to the earth, then any given body must experience a stronger pressure downwards on its superior surface than it does upwards on its inferior surface. It follows that the downwards pressure will have the advantage, and hence the body will really be pushed downwards, which effect we call gravity. And the downward pushing force, the weight of the body. And this is good old Euler. He was the #1 mathematician of the 18th century. Some of them consider him the best, I guess, mathematician of all time, or one of the top honchos there. And this is what this fellow was proposing. He was proposing ether. And here, let me illustrate that for you, what he's just said. This is what he was suggesting. He's saying, look, here you have the earth, and you have all this ether. You can think of it as a fluid made of particles. Some say it's made of a single piece, that it's not made of parts. You have all different versions out there because no one's ever defined or identified the ether. Okay, they've never started by saying, look, this is the ether, and with this thing, I'm going to be doing my gravity, my electricity, my whatever, right? No, they just went in there and said, well, the ether, that fluid that's over there, covers the entire universe, and they start using it, and they say, look, all these particles are pushing you towards the earth. And so they have this push gravity, right, based on particles or whatever they think the ether is. I put particles here because no one tells me what the ether is, so I have to tell them what the ether is, and they can challenge it. And so what's the problem? The problem is that the moon also has, this situation where all the particles are going toward the center of the moon. And so how does the earth attract the moon if all the particles over here are going towards the earth and all the particles over there are going towards the moon? So that's what you got to answer. And so Euler apparently, with all his math, he was a great mathematician, came up with the most ridiculous explanation for gravity that anybody can come up with. And that's the situation today. We have all these mathematicians. They know their numbers and their variables, by heart, like the palm of their hands. And they can't tell you how a spoon falls to the floor. That's the situation. That's the state of physics today. Okay, and then we have another aetherist, and I'm sorry to see him go. He says he quit my channel. He unsubscribed. How dare he? How dare he unsubscribe from my channel? I forbid it. And this is what he says, okay? He says, I won't even bother watching the video, the one I put last time. I'm subscribing anyway. Yeah, and so what was the issue? Well, the issue was that he ran away, with his tail between his legs. So what was this aetherist saying? Well, apparently he couldn't bear to watch. That's why he just quit. But the interesting thing is that he deleted all his comments, okay? And the only thing I'd like to mention to him, if he allows it, right, is that he forgot a couple of comments in this video that I've got by the name of titled of Aetherists and Black Holders, and he's got a couple comments still in there, so you know he hasn't gone completely away, but I'm just reminding him so that he has a chance, you know, to delete further comments. He just forgot a couple. Okay. So yeah, that's what they do. They and that's one of the reasons I don't answer comments anymore in you know, on YouTube directly. You know, I address them here. So you know what I do is I collect all these comments, these feedback, questions, whatever, and then I can analyze them and give them an answer here. And so they have an incentive to come and see me the next time. That's one issue. But the other one is, you know, if they're going to delete their comments or they're wiped out because YouTube cancels their account or whatever, well, you know, then what you see later on is that you're talking to the wind, because you see a bunch of answers and you don't know what the questions are, or vice versa. So I don't do that anymore. If you go to my early videos, you know, I used to answer a lot of questions, and today you go there and it's just blanks. People drifted away. Okay, so this is what this fellow says. He says he deleted his comments. Then he says he didn't know what the ether is. And this is how you really started. He says someone already proposed the only rational mechanism. Let me get this out. For gravity and electromagnetism, using the universal continuous fluid medium, not made of any discrete constituents. So he's got this continuous medium made of a single piece. It's flexible. It's fluid, right? That's what he thinks the ether is. And it's not made of discrete constituents. Okay, he spelled it wrong there. But the point here is, I think everybody understands this. What he's saying is this fluid fills all of space, right? Completely, meaning it's got to be finite, because hopefully space is finite if he's going to say that ether is a physical object. Physical objects are not infinite. There's no object that is infinite. All objects are finite. And so he should be able to illustrate it for us, right? So he explains it. He says some kind of fluid that is not made of discrete constituents, and he's going to use this, you know, to do his physics. Okay, that's how he starts. And he talks about proving and disproving the ether. You know, we don't care about that. We don't prove or disprove anything in physics. We need to know what or understand what your ether is so we can follow your presentation. You have to tell us what the ether is to you. I don't care what the real ether is, okay? I want to make sure that's clear. We don't care what the real ether is. But when you come and give your presentation, your dissertation, you had better tell the crowd what you have in your mind, you know, in your mind. You have to tell them, this is what I say the ether is. Then we can follow your presentation. But to say, look, everybody's got it wrong except me, you know, and then you don't tell me what the ether is to you, you know, we can't follow your presentation. That's how simple it is. Okay, so I went into kindergarten physics and I said, welcome to physics kindergarten. What is the ether? Okay, I want him to tell me what the ether is, right? And so I asked him to point to the ether, you know, and he had this. He started saying the ether is some kind of fluid, flowing fluid, or fluid that is flowing. He just kept talking about flow, you know. We never understand what these people are saying, what they're talking about, what they mean. When we don't know if it's an object or a concept. You know, are they talking about an abstract concept? Are they talking about a real thing? Are they going to use it as a baseball bat? I mean, I don't know. You know, they have to tell us. And so I just wanted him to point to the ether. And I guess he couldn't do that because this is what he said. He said here, well, first, this is what the reason I asked you is you got all these versions of the ether out there. This is the one that you'll find if you do a Google search in images. You'll find all these versions of the ether. You find all these arrows, dotted or dashed arrows. I guess they're referring to particles sweeping across the solar system. That's what it looks like, okay? And that's what people have in mind when they're talking about the ether. They think of it as some kind of fluid. Fluids are all made of particles. These people say it's a fluid. Some of them say that it's a fluid made of a single piece, that it's continuous. It's not made of constituents. Okay, fine. That's great. But then draw it. Illustrate what you're saying. I want to see the shape of the ether. See, what these people want to do is they want to say, look, the ether covers all of space. It's everywhere, right? I can't see it. I can touch it. It covers all of space. Okay, no problem. But now they want to use a chunk of that, and they say, look, the ether over here does this, here on Earth or in the solar system, whatever. You can't do that. The ether is the whole shebang. You got to move the whole elephant. You can't say, I'm going to take a piece of the elephant and do this with it. No. Ether is the whole thing. Either you use a little thing or you use a big thing. Either ether is that little thing that is a portion of something else, and you're just going to talk about that, call it ether X. Give it a different name, right? You can use ether X for whatever you want, but that's the ether. And again, you have to draw it before you do anything. But these people say it's the whole shebang. It's the ether covers the entire universe. It's a blob. It's I don't know, a fluid, floating fluid, or maybe it's a static fluid. I don't care. It doesn't really matter. And then they want to use a piece of it. No, you can't do that. You've already contradicted yourself. So this is where the problem lies. Okay. And so he says the following. He says, you want me to draw you the ether? Yeah, I want you to draw the ether, or point to a site where the ether is illustrated. I mean, if you're going to treat ether as a physical object, point to a site where I can see the ether. I want to know what you're talking about. He says, I don't know what the ether looks like. Oh, my God. So he's going to talk about how the universe works. He's going to tell us everything that he knows. And the first thing he says, I don't know what the ether looks like. He says, all supposed to be invisible and tangible, remember? Okay? Not good at drawing stuff. And that's all very childish, Bill. He says, I'm being childish because I'm requesting your word salad from him, you know. For him, all these words just go through one ear and come out the other. It's got nothing to stop it in between. Okay? Okay, does he stop there? No, he's going to tell us how light works because he knows exactly how light works. And here it is. He goes in there and he says, as for light particles, light does somewhat behave as particles. Okay, behaves somewhat like particles. Okay, whatever that means. But I don't believe they are the kind of particles many believe in. Good. I want you to show me your particles. They are not spherical beads. Okay, so they're not like everybody else thinks of beads. What are your light particles? What do they look like? Well, I mean, show me one of these particles that you have in the back of your mind. And he doesn't. He just goes in. The particles don't have any specific structure or size. That's all he said about them. He didn't tell us what it was. He didn't illustrate. He didn't point to a website saying this is what a particle looks like, the particle that I'm talking about, okay? Fine. He didn't do that. And he said, you won't find a more rational explanation for light on YouTube. And there you can see light particles explain rectilinear propagation. That's what he's going to argue. And no, the first thing anybody has to accept is that you cannot simulate either light or gravity with particles, with discrete particles. Okay? In fact, quantum mechanics gave up on that a long time ago, about 100 years ago. Before that, they had corpuscles, Newton's corpuscles, the corpuscles they were thinking about ever since the 17th century, and they gave up on that. We cannot simulate it with corpuscles in great measure because a stream of corpuscles cannot, under any circumstance, travel in a straight line, travel rectilinearly. So that already eliminates the corpuscle. We'll call it a corpuscle instead of a particle. Okay, so what does this fellow explain with his corpuscles, with his undefined corpuscles? And here it is. He says, light particles explain rectilinear propagation and reflection. The more you get near the spot where the incident ray's reflected angle becomes zero, the reflected rays are now directed towards the screen. But due to the surface being curved, what we observe is that the rays reflected many different angles according to the law of reflection, whatever that is, okay? Each reflected ray, talks about rays, talks about light. He's not talking about whether it's particles or whatever. Is making a new dot on the screen. At 0 degrees, most of the light is pointing straight and making the central maxima. Okay, how does it do it? Says, this is his whole explanation. Some rays are also deflected or diffracted inwards. In other words, you see the red dotted line there, the red dotted arrow. He's saying that it turns the corner. Turns the corner. Why? Because we have a rounded object, which in this case is a needle seen from above. Okay, it's a needle. So you're pointing the laser or the light at the needle, and the edges of the needle, he says, allow the particles to go inwards towards the red spot. And that's magic. That's never happened in our universe, maybe in his universe, I don't know. And so he says deflections explain the bending of light around corners. Yeah, we have a little bit of problem with his explanation, okay, of how he does his physics. What's the issue? Well, here's the issue. I'm trying to illustrate it here for you, okay? You throw a ball against a tree, okay, and he says it goes inwards. You know, we know that these particles, they can go towards outside, like this one here coming up. It bounces, goes outwards. That we all experience. But this one where it goes inwards, that's what we want him to explain. And he says it's just the law of reflection. I guess he's a very reflexive guy, okay? And so when I press him on that, he says, I already explained why light appears to bend around corners. I won't bother once more, okay? And again, he repeats that light reflects off the sphere near and from the edges of the circumference, which is curved. So he says it reflects, but he thinks reflection goes inwards. Reflection always goes outwards, and I challenge anyone to throw a ball against the edge of a tree and we find out that the ball will bounce outwards, never inwards. Okay, so how he gets this reflection of particles, right, to go inwards, that's where the mystery is. That's black magic. And then he just continues saying the same thing, okay? And just so you see that I'm not putting words in his mouth, okay, here's his version. This is from his website, his YouTube site. And I put this up here so that you can see how he explained. Essentially, he just said, it is so. That's all he said. Okay, you'll see how he explained the passage of light. Okay, so here it goes.
Pay attention to the red arrows. The more you get near, the spot where the incident ray's reflected angle reaches 180 degrees. The reflected rays are now directed towards the screen. But due to the surface being curved, what we observe is that the rays reflect at many different angles, according to the law of reflection. Each reflected ray is making a new dot on the screen. At 180 degrees, most of the light is pointing straight and making that central maxima. However, notice how some rays are also deflected inward, contributing to the central maxima. The law of reflection does not account for surface imperfections at the microscale, causing diffuse reflection. But those imperfections could explain the apparent bending of light around corners.
Okay, so that's his explanation of how light travels and how light turns corners. He's saying it doesn't turn corners, it's irrelevant. The point is that he is turning the corner with his light. He's turning it, he's saying it's through reflection. We don't care what reflection means. He should talk in straightforward physics language. He should tell us how a ball goes around, which is curving. That's what he's saying. He says light curves, but he's just saying it's done through reflection. No, what he's got to show is how a ball goes around a needle. That's all he's got to show us. And I'll illustrate that as well. Here it is. This is the standard version of the slit experiment. Okay, and the question is, you can see that the balls that the source is sending is hitting the edge of the slit there, the frame, you could say, right? And bouncing inwards. We all understand that because we all threw a ball against the wall and found it bounce back. So that's not an issue. This is the issue. The issue is if we're going to replace now that slit with a needle, okay, we're going to put a needle in there in the center, okay, and here it is, okay. And so if you put a needle, now you still have the fringes on the screen, but the question is now you don't have the slit there. What you have is this round needle in the center. And the question is, how do the photons or particles or whatever turn the corner? They go straight ahead. And that's a whole issue. The whole issue is that, you can't explain this with particles. Particles don't turn corners unless you can explain the mechanism, how it does that, okay? And to say it does, it's like quantum. Quantum also likes to tell you that the particles can be at any place at any point in time, because it's like, they're everywhere, right? And all at once and whatever. Well, that doesn't explain anything, because if that's the case, then it would be random, okay? You would not have the particles producing the interference pattern that quantum champions. That is the explanation today, that there's an interference, both constructive and destructive interference, and that makes the fringes. But if the quantum particle is allowed to be anywhere and everywhere at any point in time, then there shouldn't be any coherence there. We shouldn't get these fixed fringes, which is what we actually see. Okay, so here's the wave version, and that quantum also offers. And the only thing I want to mention here is when they do the slit experiment with waves, they use water waves as the simulator. And that's a problem, because light is not alleged to be both longitudinal and transverse. It's alleged to be transverse. And what they do, they have this longitudinal component, which you see there illustrated, which is that the particle goes backward. Okay? Particle goes backward, and because you get this rarefaction, compression and rarefaction going back and forth like with air, and so the particle goes backwards. That doesn't happen, or that's not proposed that it happens with light. Okay? Light is only transverse. It's not longitudinal. And they use the longitudinal component of the water waves, right, to simulate light, to simulate how the waves spread out after going through the slit and interfere with each other. And that's cheating, okay, because they never proposed that light is a longitudinal wave. Okay, it's just a transverse wave. There's no longitudinal component, which is what causes, that interference pattern right after the slits. Okay, so the issue there, part of the issue was ether. What is it? And the other issue was light. Does light turn corners? Okay, and apparently this fellow said it does turn corners, but it don't. It turns corners because it reflects, not because it swerves. That's essentially what he's saying. But he's doing it with particles, so he is, whether he knows it or not, talking about swerving. He's saying that the ball rolls around, so to speak, the needle, and goes behind, the area that is blocked by the needle, and creates the Poisson spot.